To Hanle also. Yeah.
Sir, can you introduce yourself?
Hi.
Hi.
My name is Dorje Angchuk. I'm the engineer in charge of the Indian Astronomical Observatory that you are currently in. So basically, I've been working here since last 23 years.
Oh wow.
Yeah. So that's my simple introduction.
Wonderful, wonderful, great.
Yeah.
Good to meet you, sir.
Thank you. Same here. Alright. And I'm telling you about this telescope. Basically, this is a 2-meter glass telescope. So the classification is based on the diameter of the primary mirror. So this is the primary mirror. So the diameter is 2 meters. It's called 2-meter glass telescope. And the classification is based on the mount on which the telescope is. This is an odd azimuth mount. So nowadays, with the help of computer system, you can have odd azimuth mount, and it can be very lightweight and smaller compared to the other 2-meter telescope which we have in Kabalur. That is like more than 5 times the size. So that's done. So it can move in 360 degree in azimuth. Not totally, it cannot, because of all the people constraint, it cannot go 360 degree more than it will go to some point and then come back and cover the other one. And altitude, it can go from 0 to 90 degrees. The zenith. 0 is, for us, 0 is the horizon. So not exactly, but we have some constraint because the mirror is sitting, it cannot be too vertical. So 15 degrees our constraint. Sorry, I've got some issues. Some phone call will come. So, okay, sorry. Actually, one of my car actually had an accident. No problem. Except for the car damage. So, in night, the windows of the dome open. So, the dome separately moves and follows the telescope. And this part, the white part, the telescope moves. So, wherever we are sending, that's stationary on it. We open the shutter. The dome is actually run by 1 HP motors on each direction, north, east, west, south. So it is like ulta of a train track. So here the patri moves, the wheel is stationary and it runs it. So the primary mirror is a bit concave. So the light coming from the star, it actually falls on the primary mirror and it is reflected back. That is the secondary mirror. And then further it comes down here. So this is called the instrument cube. And we can place 4 instruments at a time and use any one of them. So the light falls, whatever the star light in the telescope. So we have got 4 instruments. This is called the Hanle faint object spectrograph camera. It can do imaging as well as spectroscopy both. So this one, and here this is the CCD divar. We fill liquid nitrogen in it and keep the divar at a temperature of minus 100 degrees Celsius. And so there is an arrangement of 3 mirrors inside the instrument cube. When all the 3 mirrors are, it comes to the down port and this H-force fuse it. So in the other case, when it is like this, so when the light falls on this mirror, it is reflected to this one. This is called the high resolution axial spectrograph. So this has got much more resolution than that, 30,000 to 60,000. So and when this, the mirror which are on one axis, it moves like this. So the light is diverted to this yellow. This is called the Shark element camera. This is basically to fine tune the primary mirror and make the optical mechanical axis parallel, as well as the parallelity between the primary and secondary mirror. And then we have this third mirror. When it comes into the path, the light is reflected to this. On the other side, we have got the TIRSPEC, which is the Tata Institute of Fundamental Research, Spectroscopy and Imaging Camera. Basically, this site is best site for infrared observation, because unlike what happens in planes, because of moisture, the infrared light coming from it gets absorbed in the air, moisture. So it cannot reach. But here, this place being dry, because we have got only like 40% is the maximum humidity, we can do infrared observation here. So all these divar, they are filled with liquid nitrogen and daily to keep it cool. And this building is made up of iron and steel, because as you know, it's a good conductor. It conducts and then it releases also easily. Had it been cemented or other structure, what will happen? Throughout the day, it will absorb all the heat, and then in night it will radiate, which we will call thermal disturbance. So that will cause twinkling of the star, which we don't want. So basically, that is why this place is chosen. If you can see, this hillock is something like a pillar, and we are surrounded by flat lands throughout. So laminar wind flow is always there. So if it is turbulent, gushy, then what happens? The twinkling of the star, because of the reflection, when the light passes through different mediums, will be more. So this place was chosen like that. The reason was like when the site was initially chosen, there were 6 more contender sites. One is Hanle, second is Honorary, 2 we had in Kaza and Kalpa in Himachal, one is Nainital, Devastan, and the 6th one was, I think, Mount Abu. So people from institute, everybody went at all the places simultaneously, and they found this is the best place because it was like from Leh, if you come directly, you don't have any pass. So the roads are open throughout the year, which is actually needed for supplies because people will be working here. And we have here 180 nights, 70 or 80 nights, total cloud-free nights we get here. And usable nights are like 280 out of 365 days we get here. Wow. And like we are quite far away from, because of the Himalaya, which acts as a rain shadow barrier. As you know, there are 2 monsoon western disturbance. They actually majority things falls either on Srinagar, Sushila, Sonamarg, etc. And then only light cloud can pass. So in night we usually get clear skies. And the southeast monsoon right now, which is happening, actually everything gets deposited in Uttaranchal or Himachal. So only a few light clouds passes, and mostly it gets cleared in the night. So those are one of the reasons, and also because of the opacity, that is the transparency of this region, due to low air aerosol and low light pollution. Because here you must have seen the hills are so near, but when you start walking, then it is quite far. So that is why those are the reason why the telescope was created.
Right. Great. Wonderful, sir. So one question, how do you clean the mirrors out here?
Yes, basically in every other places, because of the rusting, they need to aluminize the mirror every 2 years. But here, since last 20 years, we haven't done.
Oh.
But only once in a year we use distilled water to clean it.
Okay.
With precautions.
Okay. Distilled water.
Yeah.
Because I see there are some pigeons also out here.
Yeah, they will always deposit. Many times, some other they will have scratches also.
Oh, okay.
There are some.
Okay, but you need to replace them then?
We cannot replace it because the primary mirror is the heart of the telescope. It takes 3 years to make. Half the cost of the telescope is primary mirror.
Right.
And if something happens to the primary mirror, then nothing is there.
But if there are scratches and all, then it affects.
Some reflectivity will come down.
Okay.
But not all.
Okay. And this is a manual finder scope?
This one, initially when the telescope was just to correct the telescope alignment.
Okay.
But then this telescope has pointing accuracy of 2 arc second.
Oh.
So wherever we want it will. Every month we do pointing model, and then it will point wherever we want to that accuracy.
Wonderful. Great. Thank you, sir.
Welcome.
Thank you so much. Thank you so much, sir. That's really nice.
So on the other side you can see the this is the infrared spectrograph camera, an imaging camera.
Okay. So this is the imaging camera, infrared.
How? Yeah, much of it. Yeah, Rangan. Chachu nandik bagyok sa kanya ang munchuru di sangal lai ka organ stan sa panga stan in the base camp. So we carry it every day and put it on in all the diwars. So basically they are at minus 192 degree and the diwar is kept at minus 100 degrees Celsius.
So they help to cool the mirrors basically.
No, the detectors.
Detectors.
Basically these are all CCTV cameras.
Okay.
So in order to get good light efficiency, we cool it. Hello.